Yeah, hi guys. Good evening. Good evening. Is the audio on? Can you give me a quick confirmation on this? Am I audible? Am I audible? Am I audible? Good evening, guys. Good evening. Good evening. Yeah, I think I had put in the wrong key to start with. Yeah, good evening. So welcome to Cat Ninjas. I think we spent little time the other day when we were discussing the numbers. We were talking about how to find the last two digits of an even number, and along with that, we did a little bit about how to find out a little bit about the application of factors. Though we didn't delve into the basics of factors, we kind of looked at how to some of the application of factors. Maybe we spent about 20-25 minutes on the day. Therefore, today we will try and spend a little more time on this particular factors so that we kind of get a grip and then we can move on to other areas of discussion in the coming lectures. All right, give a quick confirmation that the audio is clear. You are able to hear me out. Is the audio clear? Quick, somebody give me a quick confirmation. We are all good to go so that we get on to the lecture. Meanwhile, let me also check the settings at my end. Yep, all right. So Aman is saying that quite audible, not an issue. Rishti is also saying yes. Okay, cool. All right. All right. Yeah, Prashant, good evening. Good evening. Good evening, Nazia. Uh, okay. All right, cool. All right. Looks good. So let's get started. Let's get started. Yeah, as you guys wind up with a book, pen, paper, let me quickly. So as you listen, let me quickly introduce myself. Hey, I am Srinivas Belvi, and I've been working in this industry, test prep industry, since 2007. That's about 14 years now. So in these 14 years, I did develop some skills to train the students effectively in the areas of QA, DI, and LR. Yes, I worked in capacities both in terms of management as well as the training. And the training, I trained the students as well as the trainers. That's a little bit about me. And if you're seeking a short counseling or maybe a short interaction, so you can always you can always reach me out on this Telegram channel. From there, if there is anything that's short discussions that we can have those short discussions. Also, you can ask me a few things about there, and then we can proceed. You can also discuss some of your doubts among yourself, and if you think that I should get into it, so I will also interfere and probably address some of the issues. That's how we can work along on the Telegram channel. So before we start the discussion, let me quickly introduce Unacademy to you. So it offers two kinds of subscriptions. One of them is a plus and the other one is iconic. Then the plus is more about the structured discussions of the lectures from one stage to other stage, which has quite a bit of interaction, which is possible out there. Structured in the sense when I mean what I mean is some of them launch a level one kind of course in a particular chapter, level two or the level three. Some of them launch level one courses. Say, for example, on arithmetic, some of them launch level two kind of courses, level three kind of courses. Multiple courses you would see at one point in time. That's multiple batches being running there. And you can be a part of multiple batches also when you are on the platform. That's about the structured courses. And along with this, you get kind of weekly tests and certain amount of study material, all this. Now, in addition to that, Iconic also gives you a one-to-one facilitates you to have one-to-one discussions with some of your favorite mentors. So what do we do in the one-to-one discussion? You can discuss your concepts, you can discuss the doubts, you can discuss the test analysis portion. Scores are not improving. Is there a way to improve those scores? Or it can be the study plans that you can discuss based on your SWOT, how much time you should spend on what areas, which chapters you should give preference to. Such discussions can take place. Otherwise, you can also discuss about your statement of purpose, why you want to do an MBA or SBJN kind of forms or IFT kind of forms into the future. Will have a lot of questions for which you may have to answer, which are also looked seriously into the selection of the candidates. So those can be validated by one of your mentors. All those things can be, you can set up one-to-one meeting with some of your favorite mentors, and then you can have those meetings for clarity, right? Plus subscription till 30th of September, there is an offer that an extension in the time period. So you buy 6 months, you get 1 month extra, 2 months extra, and 4 months extra, and so on. And with any of the educator code, you will also get some 10% discount on the course on the fees that has been mentioned out here. So iconic. So if you are looking at Cat 21 and looking for a subscription at this point in time, I would rather suggest to go for iconic because you may need quite a bit of one-to-one discussions, which would certainly help. That is what I've seen in the past. Right, yeah. So as of now, there is an offer going on. So in this particular offer, you get 20% discount, unlike what I said, contrary to what I said as 10% discount, because the price itself has slashed till about 25th. So there is a 10% discount. Plus, if you use an educator code, you get another 10% discount, which makes 20% discount on all these kind of listed prices. Whatever has been listed here, you can avail 20% discount on these listed prices. That's still about 25th, I guess. Right? Yeah. I'm happy that most of you are taking the test. So Sunday is coming up. Therefore, plan for your Sunday. Today we are on Friday. Come Saturday and then Sunday. So on Sunday, I expect that all of you would write a mock test, full length mock test, especially in the area of CAT. So since you are serious about it, that's what something you should do. And these are some of the batches which are about to be launched tomorrow. You can look to the course offerings, and then if something suits you, probably you can follow that particular batch on the Plus platform. Yeah, that brings us to the closure of the discussion. Announcements. Yeah, quickly let me know who are all plugged in here. So can I quickly know and exchange the greetings who are all here? Quickly let me know, guys, so that we can proceed. How many of you are here today? Okay. Okay. How many of you are active? How many of you are? So you can plug something in the comment. That's a live chat. Yeah. Hi, Nazia. And who else? Quickly, whoever is there, can you guys quickly plug in something there? Okay. I'm an active. All right. I'm hoping that all of you are sitting with a book and a pen. Just that whoever is active, put something out there. Yeah. Okay, Aman. All right. Mohit is joined. Good. Who else? Quickly plug in, plug in, plug in. Plug something in the live chat. Okay, Kishan is here. All right. Hello, Kishan. Who else? Nazia, Aman, Mohit, Kishan. Okay, Prashant. Yeah, Prashant. Who's this? Clippers. Can you put your name? In all likelihood, Clippers may not be your name. You can put your name so that it would be nice to call by that. Okay. Great. All right. That's good. That's good. That's good. Deepak. All right, Deepak. Okay. What does the Clippers mean, Deepak? How does Clippers come in the picture? You can text leisurely. At your leisure time, you can text how that does come in the picture. All right, guys. So as we do, let's start with a cat question because we kind of developed orientation to in the last 30 minutes of the previous lecture. We did a little bit about the factors, right? We kind of pushed our brain a little bit about the factors. Therefore, this should not be a very difficult question as such. So why don't you guys try it for about a minute? So I will start with quiz today. We will start with quiz. We are doing on the job training. Technically, what we are doing is we are doing on the job training for the factors. I'm not teaching what is the basics of the factors, etc. But as and when we are doing a question, naturally we are revisiting those concepts, no doubts about it. But yeah, but since we are not doing that kind of study where I will teach you what the factors is and then we'll come to the question, the approach that we have taken on the factors is what we have taken on the job kind of training. We do it along, knowing that probably would have done a little bit of pre-reads about the factors, as I already mentioned in the previous lecture. Let's go ahead. Let's take about a minute here. Let's take about a minute here. Why don't we take a minute and answer this particular question? All of you, push your pencils, keep your book ready. Don't lie down on the bed or on the sofa. So sit straight, probably use your book and pen and start working alongside me because we are doing on the job training, right? Of course, I will give the background to each of these questions as we go along, no doubts. But then let's do on the job training as we start. It's a cat question as it is. Cat question as it is. One of the cat questions as it is. Okay, what happened, guys? Are you still plugging your books and pens? And what is happening? Can you first confirm me that you are sitting with your book and pen, everyone? Can you put something in the chat? Yes. Are you sitting with the right, Mohit? Thought is right. Are you sitting with book and pen? Why you are giving me the thought, Mohit? You can give me the number, right? So which means you are not sitting with a book and a pen. Is my conclusion right? Then sit with a book and pen. Yeah. If you are giving a thought, but if you are not able to work, then you have it. Okay. All right. Okay. 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 Yes. All right. Good. Yeah. Someone by name Young Savage. I don't know why you keep that name. So, nevertheless, can I complete numbers if I start now? Why not? Numbers is just one chapter out of many chapters, and you still have 60 odd days. Good, guys. Good. All of you are sitting with book and pen. That's pretty encouraging. Let's start. Let's start. Let's start. What did we discuss in the previous lecture? We already kind of discussed. It's just an extension to that thought. We said that, hey, so perfect square. This is the kind of thought we discussed. We said that if the given number is not a perfect square, I'm just repeating it because I already mentioned this. If the given number is not a perfect square, then it would have even number of factors, right? Even number of factors. Factors. How many factors would be there? The factors would be always even in count, right? Always even in count. Then you said that, hey, given number n is a perfect square, then it would have odd number of factors. If the given number is a perfect square, then it has odd number of factors, which means it can have one factor or three factor or five factors, etc. Then we kind of made a study about this. Hey, if this particular number is a square of a prime number, if it is a square of a prime number, how many factors, guys? How many factors? If the given number is a square of a prime number, how many factors it would have? Quick, quick, quick. Put it in the chat. Put it in the chat. If the given number is a square of a prime number, there is a number that's a square of a prime number, how many factors it would have? How many factors it would have? How many? Yeah, that's right. Three factors. All right. It is a subset of this odd, but it has exactly three factors. Fantastic. So you remember, this is all the summary. Therefore, this question is simply built on this. This was one of the CAT questions simply built on the understanding of this, right? Understanding of this. There are many ways to understand factors. We will discover as we go along. We will discover maybe a couple of them. But this has been already covered in the previous lecture. When I was talking, I already mentioned about it. Therefore, this statement is important to me. This is what I'm looking at. Why? Because author is saying that, hey man, it has even number of factors. That's a key word. It has even number of factors. Correct. Okay, then first 100 even numbers means what? What is the sample size? Of course, you don't have to write it. This is what would be flashing in your mind. You would say that, hey, the number set, so subset number set is 2, 4, 6, 8, 10, like this up to 200. This is what flashes in your mind. Hey, should I write this? No, you don't have to write this. First 100 even numbers means what? Starts from 2 and ends at 200. First 100 natural number would start with 1 and end at 100. But first 100 even natural numbers starts with 2 and ends in 200. That's my sample size. Most of them would have even number of factors except the numbers which have odd number of factors. Okay, what kind of except the numbers which have the which are the perfect squares. Which perfect squares would be even? Naturally, the square of an even number would be even in the sense, hey, here it is the 2 square here, right? Similarly, you would have a 4 square, that is somewhere here would be 16 here, right? 12, 14, like that. When you are writing 4 square, I should eliminate, right? Say 8 square, I should eliminate, like this. Hey, what can be one of the perfect square which is even, which comes before this? We all know that, hey, 196 also comes after that. 198 is there, no doubt about this. 196 is a perfect square. It's a square of what? 14 square. Therefore, you are saying that 2, 4, 2 square, 4 square, 6 square exist, 8 square exist, 10 square exist, and 12 square exist, and 14 square exist. Now, this sample size, all of these numbers are a part of this journey, right? 4 exist here, 4 square 16 would exist here, 36 would exist here, because all these even numbers up to 14 square, which is 196, exist there. Therefore, how many numbers I should discard? My total sample size is 100. How many are not in favor out of this? 1, 2, 3, 4, 5, 6, 7. 7 numbers are not in favor. Therefore, 93 numbers are in my favor. Answer is none of these. Comfortable? Everybody comfortable? Very simple question. Yeah. Very simple question. Honestly, very simple question. Maybe because it's a first question, the mind would be a little jittery, right? In a sense, it's the mind is still not warmed up. Therefore, it can take some time. Otherwise, it's a very simple question. Agreed? All done? Any doubts? Very simple question. No big deal. Yeah, sometimes the cold start. These are the issues of the cold start. We take more time in the first few questions. Cold start. Cold start is a typical issue even while writing the tests also. First few minutes will be slow, and then slowly we pick up the momentum, which is the usual problem to most human beings. Absolutely no problem. That's fine. So I can understand cold start when you didn't answer this. Okay, here goes another cat question. Why don't you try this and give me answer in about a minute or minute and a half? I will start with a minute. If required, I will extend. Try, everybody try. Go ahead, use your pen, use your paper. Everybody give a great try. Hmm. Fine. Listen, all of you listen. Do it with me. All of you listen. If I give a little more time, you guys will close it. That's not a problem. Listen, guys, listen, listen. It's okay. On the job training. So therefore, I'm reflecting the question first and then I'm doing it. Other way around is what? I will teach you full stuff and I will do, right? It's a deliberate decision that we have taken with respect to factors. Just trying various different things out here. Okay, let's take a look here. Let's take a look here. Let's say what did we learn as a concept while we are trying to find certain factors. Let me take this number to start with. Say my number is 72. What we learned there, first understand this. So because there is a fundamental principle of counting here, isn't it? So once we understand that fundamental principle of counting, we can find perfect square, perfect cube, because concept remains same. They might want to put some conditions on this perfect squares, etc., etc. Let's understand the first, what is the principles of counting involved in this, because all of you understand a little bit of permutation combination. That should not be a major problem to teach this particular concept. Let's say, hey, what is this 72? You say that 72 can be written as 2 raised to power 3 and 3 raised to power 2. This is my 72. I will write my number 72. What did I do? I expressed this as a prime. I expressed as prime. This is how it looks. What does it mean? What does it mean is, hey, I will take 3 cards on which 2 is printed. I will take 3 cards on which 2 is printed. Cards. These are the cards. I will make a cut out a card on which I will just print a 2 and I will keep it on the table. I will take 2 cards on which 3 would be printed. On which 3 would be printed. This is my sample size. Simple. That's it. That is my sample size. Assume that these are the cards with you. Time being, assume that, hey, these are the 5 cards with you. There are 3 cards on which 2 is printed, which is with you, and there are 2 cards on which 3 is printed, which is with you. That is what I'm trying to tell you. Fair enough. So I have a card called as 1. So now these are the cards on the other side of the screen, that is in your study room, and this is the card at my work table. This is the only one card that I have. This card is called as 1. I will tell you guys, give me the cards. You say that, sir, I will not give you any cards. I need all 5 cards. Keep it. Therefore, I say that my factor is called as 1. 1 is my factor. Then I said that, hey, give the cards. You said that, okay, I will give you one card called as 2. Take this card. Okay, you gave me this card as 2. Therefore, my factor, my factor has become 1 into 2. 1 is always with me. One card I always have. I'm not pauper. It's not pauper. I will always have one card on which 1 is printed. If you give me a 2, I will make it 2. You will say that, hey, I will give you 2 cards, sir. Okay. Therefore, now the new factor is 1 into 2 into 2. 4 is the new factor. Then you would say that, sir, I will take back one of the 2's. Okay. Then instead of that, I will give you a 3 along with this. Okay. Therefore, 2 into 3 is the factor. Then you say that I will take both the 2's, both the 2's. I will give you 2 3's to you. Therefore, you say that, okay, 3 into 3. 9 is the factor. Technically, what is that you are trying to say? All you are trying to say is this. You are saying that, hey, 2's I can deal it in 4 ways. What do you mean by 4 ways? I will not, no card on which 2 is printed. You were saying that no card on which 2 is printed. I will give one card on which 2 is printed, or I will give you 2 cards on which 2 is printed, or I will give you all 3 cards on which 2 is printed. That's what you are trying to say. I can deal with 2's in 4 ways. That's what you are trying to say, right? Okay. Now, similarly, coming to 3's, you are saying that I can deal with 3's in 3 ways. What do you mean? I will not give you you any card on which 3 is printed. No card I will give you on which 3 is printed. Or I will give you one card on which 3 is printed, or I would hand over both the cards on which 3 is printed. This is what you are trying to say. That's the meaning of 3. What is this? Hey, this is PNC, what I'm talking here, technically. Therefore, how many ways you can deal with a combination of cards? Fundamental principle of counting, I have to deal with 2's and I have to deal with 3's. Therefore, you say that 4 into 3 is equal to 12. This is what you kind of wrote this as, if the n can be written as prime 1 raised to power a, prime 2 raised to power b. You looked at this a and you said that a plus 1, and you looked at this b and you called it as b plus 1. Fair enough. This is the concept. Alright, technically this is the concept of fundamental principle of counting, in which we are counting the cards. Counting, alright, counting of how many factors. Now listen to this. What is that I'm trying to say? Here you are saying that, now come back to this question. I want perfect squares. Now what I do is, hey, there are 7 cards on which 2 is printed. Let me just show it to you once so that it sticks in your mind and you never commit a mistake on this, right? So 7 cards on which 2 is printed. If I want a perfect square, I will pin them. I will take 2 cards and I will take a stapler and I will pin it. Now don't try to do all of this. Just an illustration so that it sticks in your mind. That's it. Take 2 cards, because if I have to deal with perfect squares, you cannot hand over one card to me. Therefore, I said that, hey, look, all it now say Mohit or Nazia, whoever, Yash, somebody on that particular side. So now don't take that Srishti, all it's maybe saying why you are not taking my name, or Prashant not taking my name. Just a sample size. I'm just telling you that, okay, now I'm dealing with somebody, Mohit, let's assume. Right, Mohit, I said that, hey, Mohit, whenever the factors you give, it should be a perfect square. Then Mohit will think about it, what I should do. Hey, take 2 cards, put a stapler. Because by accidentally, I don't want you to give one card on which 2 is printed, then it will never become a perfect square. Give 2 cards on which 2 is printed. Tie them, bundle them, bundle them. Now Mohit may say that, sir, one card on which 2 is printed, discard. If it is printed, I can't help it. Therefore, what is that you are trying to say? 3 bundles you have, all right, 3 bundles you have. Similarly, 3 cards on which 5 is printed, bundle them, take 2 3s and bundle, take another set of 2 3s and bundle. You may say that one card on which 3 is printed is left, discard it. I can't help it, right? Similarly, 5 bundles you can do, all right, double 5, double 5, double 5, double 5, double 5, like this. You can do 5 bundles of 5s because you have 10 cards there, 5 bundles. Okay, technically, what is that I'm trying to say? When you can make 3 bundles, you can deal it in 4 ways. When you can make 2 bundles, you can deal it in 3 ways, because you need not give me any bundle also, right? So technically, therefore, okay, now how do I summarize? Hey, sir, should I have to write all of this to do it? No, this I helped you to visualize. Make the bundles. If it is a perfect square, whenever you are trying to give me 2's, let it be a perfect square. You say that I can write 2 power 7 as 2 square. I will have 3 bundles. 2 square 3, 6 cards I use. 7th card I can't use. Fine, if you can't use, leave it. Okay, come to this 3. You say that I make a bundles 3 square. 2 cards of 3's I take and I put it as a bundle. I would have 2 bundles. 1 3 will be left. Leave it, because if I cannot use it, I can't use it. Can't help that. Okay, similarly, 5 raised to power 10. I make a bundle of 5's. How many? 5 bundles I do. Then 7 square, I would have 1 bundle. Now what is that? Every time when you put 2 together, it has become a perfect square there. So now can I use 1 bundle from here and 1 bundle from here? Will it remain a perfect square? Of course, yes. Because 2 square is 1 bundle, 3 square is another bundle. If I use 1 bundle, 1 bundle, naturally the whole figure is going to be a perfect square. You can't say that, sir, from this side I will use 2 square, from this side I will use 3 power 1. No, it should be given in pairs. If I want a perfect square, naturally the card should be supplied in terms of pairs. Now apply the principle here. If you have 3 bundles, you can deal it in 4 ways. If you have 2 bundles, you can deal this in 3 ways. If you have 5 bundles, you can deal it in 6 ways. If you have 1 bundle, you can deal it in 12 ways, right? So therefore, multiply all of them, which would become 144. That is the answer. Guys, principle is clear, everybody? Very good. Principle is clear, everyone? Now the principle is clear. Principle is clear. This was the cat question as it is. I didn't change anything. This is the cat question as it is, it appeared. Cat question as it is appeared. Principle of counting remains same. It is not a formula. A lot of people think that this is the formula. It is not just a formula. It is the principle of counting. Alright, it is a fundamental principle of counting similar things. As simple as that. If you know the principle of counting, you can count whatever you want. Perfect squares, perfect cubes, whatever. Okay, guys, let me change this question. Let me change this question. So if you have understood what I said, why don't you give me the answer quickly now? Instead of perfect square, if I say that perfect cube, alright, number of perfect cube factors. Now give me the answer. Same number, same number. Answer options need not match. Give me number of perfect cubes quickly. Good, very clear, very good. Now give me the answer, Nazia. All of you, not just Nazia. Give me the total number of perfect cube factors of the same number. Perfect cube, total number of perfect cube factors of the same number. Hmm. Superb. Superb. Hmm. Right. Right. Very good. Very good. Superb, guys. Yeah. Just have to make bundles of three. Absolutely. 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 Superb. All right. Now I will not solve it. Your answer 24 is right. Okay. Just in case you want me to solve. If anybody is still struggling, let me solve as a matter of fact. Otherwise, it appears to me that you are all very, very clear with what I'm talking. 2 cube, you have two bundles, right? Because you have 7, therefore you can make that. 3 cube, you would have only one bundle. You will say that some threes are getting wasted. Sure, let it get wasted. Can't help. 5 cube, you would have 3 bundles. 7, 0 bundles. You can't even use 7 for it. Therefore, you would say from here, hey, this is 3, this is 2, and this is 4. Right? Therefore, 24 as you guys printed in the choice, that's correct. All right, let's go to the next one. Let's go to the next one. Yeah, think about it for a minute. Beautiful question. Think about it for a minute. Yeah, think about it for a minute. Go ahead, everybody think about it for a minute. Beautiful question, opens up the concepts nicely here, nice and fine. Think, everybody think. Hmm, good. All right, listen, guys. What is the underlying concept here? Very good. Now, listen, everybody, listen here. What's the underlying concept here? Another way from high school. So, we looked at one way of dealing with the factors. Another thing, all right, these are all very fundamental ways of visualizing the things. What is it here? Always remember, number of, if I have a number called n, number of factors less than root n will be equal to number of factors more than root n. Right? Always remember, number of factors less than root n will be same as n is a number. I have a number n. Number of factor less than its root would be equal to number of factors more than its root. It is simply dependent on this concept. As simple as this. Let me take an example to illustrate. Okay, let's say my number is 18. This value n is nothing but 18. Let me write number as 18. I will write root 18. I don't want to evaluate what is root 18. That is not the idea. Root 18 is nothing but, hey, this is 4 point something. What is that point something? That's another day study. Let's say call it as a 4 point something. 4 point something means what are the numbers that come before this root 18? 1, 2, 3, 4. These are the only 4 natural numbers which come. Is 1 a factor of 18? Yes. Is 2 a factor of 18? Yes. Is 3 a factor of 18? Yes. Is 4 a factor of 18? No. Therefore, there are three factors. There are three factors of 18 less than root 18, which implies there would be exactly three factors which will be greater than root 18. What is that? 1 into 18. Multiply with this. 1 into 18 is equal to 18. Okay, 18 divided by 1. 18 divided by 2. Write the second one. That becomes 9. 18 divided by 3. Write the third one, which becomes 6. Which means if there are three factors less than the root of that number, there would be exactly three more factors more than the root of that particular number. Let me take another example to illustrate that, because this has to be clearly visualized and understood. Understood, very clearly visualized and understood. Fair enough. Let me take just another number there. Say my number is 28. Say my number is 28, right? No, so number is 28, root of 28. Hey, what is root of 28? 5 point something. In a sense, you are visualizing the numbers as 1, 2, 3, 4, 5. These are the 5 numbers that you got to think of. Is 1 a factor of 28? Yes, retain it. Is 2 a factor of 28? Yes. Is 3 a factor of 28? No. Is 4 a factor of 28? Yes. Is 5 a factor of 28? No. All right, so therefore these are the 3 factors. You are saying that, hey, 1, 2 and 4 are the factors. Implies on the other side of root 28, on the other side of root 28, 1 divided by 28 divided by 1, 28 divided by 1, 28 is another factor of 28. 28 divided by 2, 14 is another factor. 28 divided by 4, 7 is another factor. What I'm trying to say is number of factors less than the root of the number is always equal to number of factors more than root of that particular number, and hence if there are n factors less than the root, there is always n factors more than the root. Therefore, total number of factors is going to be 2n, n plus n, which is nothing but 2n. So n can be odd or n can be even, doesn't matter, but 2n is always even. Now let's take one example of a perfect square. Say for example 36. 36. Then what is root of 36? Now you are talking about root of 36. Root of 36 is 6 itself. Hey, therefore already you got one extra factor there. So number of factors less than this. So you are examining 1, 2, 3, 4, 5. Does 1 divide 36? Yes. Does 2 divide 36? Yes. Does 3 divide? Does 4 divide? Yes. 5 does not divide. And hence you will have exactly 4 more factors on the other side. 36 divided by 1. You are writing on the other side here. 36 divided by 1, which is 36. 36 divided by 2, which becomes 18. 36 divided by 3, which becomes 12. 36 divided by 4, which becomes 9. So therefore, if there are 4 factors less than the number, less than the root of the number, there would be 4 factors more than the root of the number. If the number is a perfect square, that root also qualifies. And hence you are saying that if n factors are less than the root of the number and n factors are more than the root of the number, there will be another one fellow in between. And hence you are saying that, hey, it is going to be 2n plus 1 factors. And hence you said that it has odd number of factors. The perfect square has odd number of factors. This is the concept. This concept comes from high school. I'm not telling anything out here. From the high school, you kind of learn this. Let's come back to this question. This is the background required for this question. The moment you read, look, this is n square. The number is n square. You have a number called as x, and it's a perfect square. X is the number. X is the number which is already a perfect square. X is the number which is already a perfect square, such that exactly 6 factors are less than n. Okay, let's say that n is a natural number. So n is a natural number. It's such that exactly 6 factors are less than n. So n, the number n square, where n is a natural number, is such that exactly 6 of the factors are less than n. What is that you are trying to say? Hey, there is an n square. This is the number. My number is n square. Take the root of n square. When you take the root of n square, it becomes n. Author is now saying that 6 factors are less than n, which implies 6 factors will be more than n. 6 plus 6 is 12, and the root also qualifies as another factor, and hence you are trying to say that number of factors of n square is equal to 13. Guys, give me a quick confirmation at this stage that you understood so far. Number of factors of n square are 13 is clear to you. 6 factors are less than n, therefore 6 factors are more than n, because the given number is a perfect square. I don't know what is that number. It's a perfect square. 6 numbers are less than the root of it. 6 numbers are more than the root of it. Therefore, together it has 13 factors, because n also qualifies. Clear? Roshni, you are asking that what time my class starts. 10ish in the night. About 10 in the night, and also sometimes 2 in the afternoon. Okay? All right, good. All right. So far it is good. Therefore, now coming to this. If the number has 13 factors, the number of factors are 13, then n square should be n square should be of the form p raised to power 12. That is the only way, right? So p raised to power 12. What you are trying to say? Factors of n square are 13 means what? My n square should be of the form prime raised to power 12. That's the only way. Therefore, it will have a plus 1 factors. It would have a plus 1 factors, nothing but 12 plus 1 factors, which is equal to 13. And hence you are trying to say that n square is some prime. Which is this prime? Is this 2? Is this 3? Is this 5? I have no idea. It is a prime number. That's it. Some prime raised to power 12. If n square is equal to p raised to power 12, from here I'm deducing from here. If n square has 13 factors, which is a plus 1 is equal to 13, right? If a plus 1 is equal to 13, what is the value of a? The value of a is equal to 12. So because whenever you write something like that, right? A plus 1 is equal to 13, therefore a is equal to 12, which means n square is equal to prime raised to power 12. From here, what is n? Therefore, take square root on both the sides. It is some prime raised to power 6. What is n cube? Therefore, prime raised to power 18. Therefore, what is the factors of n cube? Factors of n cube is 18 plus 1, which becomes 19. Which becomes 19. So far it is clear? So far it is clear? So far it is clear. You got this 13 factors. Because you got this 13 factors, you wrote this, and hence you figured out the factors of n cube. It is clear. Now shall we go to a cat question? Let's take a look at the fact cat question now. Yeah. So here comes the cat question. Try this. I will give a minute. I will give a minute. Close this in a minute's time. Having understood the concept, close this cat question in a minute's time. Go ahead. Everybody go ahead. Mm, mm. I'm watching. I'm watching your response. Yeah. Yeah. All right. All right. All right. Great. All right. Okay. Okay, so watch out. All right, now look at this. Could be possibility. All right, now look at that. Right, retreat. So because we'll be in a hurry, right? Even in the cat, we'll be in such unnecessary hurry. Look at keywords. Always look at them. If they are talking about possibility, they meant something there, right? What could be the number of factors of n cube, right? Possibility. Why this fellow is talking suddenly about a possibility, which means there is no certainty, right? When they are talking about a possibility, there is no certainty there. That is the meaning of this particular part, right? Okay, now let's take a look at this. The number n square, where n is the natural number, is such that exactly 7 of its factors are less than n. Listen to this very carefully. All of you, stop typing now. Start listening. Start listening. Let's understand why this word could is coming in between. See, you got to read critically, my friends. I keep telling you, you got to notice sensitivity is required when you are reading the question, especially quant questions. How much big the quant question would be? Maximum 2 lines, 3 lines at the most. If you're reading time, speed, distance question, what about 3 sentences? Read critically. All right, read critically. Possibilities, certainties. Watch out for those words. They mean a lot because they will be trying to send some signal which we kind of try to miss out because all right, we are not sensitive to certain words being used. All right, any which ways. All right, now so I keep telling this in LRD especially. Ensure that you are sensitive to certain words there. Okay, certain words there. Coming to this, the n square has solid. Now what is that? So it's exactly 7 factors or less than n. Fair enough. You have a number called n square. You take a root of n square. When you take a root of n square, naturally the mid value becomes n. Author is trying to say that 7 factors are this side. Therefore, 7 factors would be on the other side as well, which implies 7 plus 7 plus 1 factor here because the n is also a natural number. And hence you are saying that together I have 15 factors. Technically, you are trying to say n square, or number of factors of n square or 15. Number of factors of n square or 15. It means two things to us. One, your n square can be of the form n, because now look at this, 15 can be written as 15 into 1. 15 can also be written as 5 into 3. You may wonder, what is this? Let me come to this. This 15 is nothing but a plus 1, because number of factors are written like that. This is written as b plus 1. Just as a symbolic, I'm writing this. All right. Fine. In this case, let us take a look at only the left hand side of the picture, which implies if a plus 1 is equal to 15 here, therefore a is equal to 14. If b plus 1 is equal to 1, therefore b is equal to 0, meaning n square can be written as some prime raised to power 14, prime 1 raised to power 14, and prime 2 raised to power 0, which means prime 2 does not exist. Let me not worry about that. Prime 2 does not exist. N square is equal to prime 1 raised to power 18 implies n is equal to prime raised to power 7. N cube is equal to prime raised to power 21. Therefore, factors of n cube is equal to 21 plus 1. 21 plus 1, which is equal to 22. That is one side of the answer. Now listen, come to the other side of the answer. Let's take a look here. Let's come to the other side of the answer. 15 can also be written as, let me write it here. Factors of n square is equal to 15. I can write this 15 as 5 into 3, meaning a plus 1 is 5. B plus 1 is equal to 3. B plus 1 is equal to 3. Fair enough. Therefore, what is the value of A from here? Value of A is 4, because A plus 1 is equal to 5 means what is A? It is nothing but 4. B plus 1 is 3. What is B? B is equal to 2. And hence, what is that you are trying to say? Hey, n square is nothing but prime 1 raised to power 4, because this is the 4. There is one prime which is raised to the power 4. There is a second prime which is raised to the power 2. This is what you are trying to say. Great. Therefore, what is n then? N is equal to prime 1 raised to power 2 and prime 2 raised to power 1. Okay, what is the n cube? N cube is prime 1 raised to power 6 and prime 2 raised to power cube. That is n cube then. From here, what are the factors of n cube? Therefore, 6 becomes 7 and 3 becomes 4. 7 into 4 is equal to 28. I have two answers. One answer can be 22. Another answer can be 28. Therefore, author said that which of the following could be? Could be is nothing but which of the following could be? I would rather say 28 is already there. Therefore, 28 is the preferred answer. Hang on. Now, let me explain. Why didn't I do this in the previous question? That is the doubt you get. Sir, you are already now you tried to split this 15 like this. Why didn't you do this? Capture this number. What is this number here? 15. Okay. Capture that number. Let me go to my previous slide. Let's go there and take a look at this particular number. What is this number here? 13. 13 is a prime number. All right, now look at this. This 13 is a prime number. Prime number cannot be factored. Prime number cannot be factored. 13 cannot be written as a factor of two numbers. 13 is 13 into 1. But what is the point writing 1? You may say that 13 is a plus 1. This 1 is b plus 1. Then the value of b is naturally 0. Value of a becomes 12. And that is what we kind of used here. Therefore, we could not split that particular number. However, 15 is a composite number. 15 is a composite number. I can write 15 as a factor. I can write a 15 as its product of its factors. One way, I could write it as 15 into 1 itself. Therefore, I got one answer. 15 can also be written as 5 into 3 itself. Therefore, I got another answer. There is no third way to write it. You can't say that 15, I can also write it as product of three numbers, which means you could say that I will write it as 15 into 3 into 1. If you write 1, you know that by now it is useless, because c plus 1 is equal to 1. C becomes 0, right? Because you would have used a plus 1 here and b plus 1 here. So my point, all right, that's a point there. Whatever you write greater than 1. 1 will be meaningless, right? Anything greater than 1 can help. So point here is very simple. Notice if it is a composite number, more than one answer exists. If it is a prime number, exactly one answer exists. Point clear, my friends, everyone? Point clear? And how did he give that clue? He gave that clue by using the word could. He used the word possibility. He used that word very clearly, possibility. That should have alerted us. That should have alerted us. Understood? Understood, everybody? Okay. Very good. All right. Guys, other than Prashant and Mohit, others are still wondering, not clear what we are doing. Mohit, you are saying that should the factors be split only as a product of primes? No, product of primes. I will give a question here. All right, that will clear. Sir, if 22 is given in the option, what will we mark? Mark 22. How author can give both, Shashi? He can't give two, no? Then he has to change the answer option. Assume that this number was 22. This number is 28. Then he will change this more than one of the above. More than one of the above. He will write this as more than one of the above. Or he will change this answer option. Already he will change this answer option to both A and B. Both A and B. See, he will create answer options logically. I don't have to worry about it, right? If he says that, okay, first answer option I gave 22 also, here in C I gave 28 also, then change D to none of these to more than one of the above if they are printed one below the other. Generally in this radio buttons will be there one below the other. 22 would come here, 18 comes here, 28 comes here. Then you better print this more than one of the above. Then I will click this radio button or change this to either A or C, something like this. If you call this as A and if you call this as C, then change it to A or C, something like that. You have to create answer options logically which suits your question. That much thought authors will put. Don't worry. They won't trouble us like that. Right? They won't trouble us like that. That much thought they also will put. Okay? Yeah. So that's a point there. See, if they have put the could, then one answer option would have been printed out there. Okay? I hope you are getting the point. Okay. So this is the answer to Rohit's question. So tell me that, okay, I have a number. The number has 72 factors. All of you can solve this. A number has 72 factors. Tell me what is the minimum. Number has 72 factors. Find the minimum number of prime factors. Minimum number of prime factors the number has. Find the minimum number of prime factors the number has. Number two, find the maximum number of prime factors the number has. Find the maximum number of, I don't know the number. I don't know the number. I am telling you that my number has 72 factors. I'm just telling you, I have a number with me. That number has 72 factors. My question is, what can be the minimum number of prime factors? Because when I said 72 factors, all of them need not be prime, right? Therefore, what is the minimum number of prime factors the number has? What is the maximum number of prime factors the number has? Go ahead, friends. Everybody solve this. Everybody solve this. A lot of things about factors will get clarified with this example. Go ahead. What is the minimum number of prime factors that n has? Number means n. Minimum number of prime factors of n and the maximum number of prime factors of n. Minimum number of prime factors of n and the maximum number of prime factors of n. Go ahead. Plug it. Think about it. Right, Rohit, this answers your question, right? Your doubt would be answered here. Simple. If the number has 72 factors, try splitting that 72. 72, all it has 72 can be written as 72 itself. All it 72 is just 72. I don't want to split it any further. Case 1. Case 2, I would say that, sir, I will write 72 as 36 into 2. Right, at least 2 because no point writing 1 because a plus 1 b plus 1, that 1 becomes meaningless. You can write it like this. You can also say that no, I will write 72 as 18 into 2 into 2. Fair enough, you can keep writing it like this. What is the meaning of this? You are trying to say this 72 is equal to a plus 1 because total factors are 72. A plus 1 has given you 72, therefore a is equal to 71, meaning your number is prime raised to 71. There is only one prime, therefore number of factors, it has only one prime, rest are composite. Had it been something like this, 72 is written as 36 into 2. Why? Because before you generate the factors, you would have multiplied some numbers to get that factors. In the sense, you would have written this as a plus 1 and b plus 1. This 2 is nothing but b plus 1. A plus 1 plus b plus 1. Therefore, what is the value of a? 35. What is the value of b1? In the sense, you are trying to say your number was prime 1 raised to power 35 and prime 2 raised to power 1. Implies you had two factors. Alright, you had two prime factors. Therefore, what is that you learned? You learned that, hey, divide, look at this 72. Now you are trying to say that a plus 1, naturally b plus 1 and c plus 1. When you are writing a plus 1, b plus 1, c plus 1, it naturally has three prime factors. Therefore, what do you learn? You learn that break this 72 into as tiny pieces as possible. the value of each factor should be greater than 2. When you write a plus 1, b plus 1, it should be greater than or equal to 2. Write that 72, break them into as many tiny pieces as possible. 2 into 2 into 2 into 3 into 3. This is how you get your 72, which means what? Hey, for looking at this, it was prime 1 raised to power 1 because a plus 1 was this 2. B plus 1 was this 2. Therefore, what do you write? Prime 2 raised to power 1. There was another prime involved to the power 1. There is another prime involved to the power 2. There is another prime involved to the power 2. So therefore, you say that there are 5 prime factors. P1 is a prime factor, P2, P3, P4, P5. It has 5 prime factors. Okay, this kind of addresses your question, right? This kind of addresses your concern. So whenever you factorize this, it need not be primes. It is not 5 into 2 to be primes, because when you did this, hey, you can also write it as 18 into 2 into 2. Many ways you can write. Many ways you can write. Maxima, minima, when we do it, we generally break it down into smaller fractions, right? When we want the maxima. Otherwise, I just want some factors, no problem writing it as 18 into 2 into 2. No problem writing it as 36 into 2. I hope it has given some clarity. It has given some clarity. Let's move further. Let's move further. Right, take another beautiful application question. I hope all of you know how to find sum of the factors. What is the underlying concept? How do we go about this? Just think about it for a minute. Think about it for a minute. Then we will come back and resolve. Think, everybody think about it. Beautiful application questions. Okay. All right. Fine, listen guys. Now this is what? This is the application of sum of the factors. If you look at this particular question, this is application of sum of factors. Sum of factors. Let me quickly prove this. Now listen to me. Let me take 72. Let me not take this big number. Let's say that my area of the rectangle. Listen, all of you listen quickly. Area of rectangle. Let us say that area of rectangle is 72 square units. 72 square units. Area of the rectangle is 72 square units. I have not taken this number because 72 I can show you. Therefore, I have taken 72. Let the area of the rectangle be 72 square units. Okay. Yeah. And the sides are integers. Otherwise, 72 can be written as some fractions also. The sides are integers given. Integral side. I just change the number to 72 to illustrate, and then we'll come back to this question. What does it mean? All right, 72. Now list the factors again. One is a factor A. What is the root 72? Let's do it manually. Root 72 is nothing but 8 point something. Okay, let me list it. 1 is a factor, 2 is a factor, less than 8 up to 8 I'm listing. 3 is a factor, 4 is a factor of 72, 6 is a factor, and 8 is a factor. Now which also implies, now listen to this. Other side, how I'm writing? 1 into 72 is 72. 2 into 36 is 72. 3 into 24 is 72. 4 into 18 is 72. 8 into 12 is 72. Sorry, 6 into 12 and 8 into 9. These are the 72. In fact, this is the rectangle. These are the dimensions of rectangle. One side is 1, the other side is 72, which means when I want me to draw the first rectangle, it might look, this is the first rectangle, it might look something like this, a slender strip. 1 across 72. This is 1 and this is 72. Similarly, I can draw this also, the last rectangle. It might look something more like a box, appropriate box kind of, right? So this can be 9 units and this can be 8 units. Like this, I can draw all these possible rectangles, which means what is this? They aren't they factors? Isn't 1 a factor? Isn't 2 a factor? Isn't 3 a factor? Isn't 36 a factor? Yes, these are the 12 factors of 72. It forms a logical pair. 1 forms a pair with 72, 2 forms a pair with 36, 3 forms a logical pair with 24. Likewise, that is how I am generating. Means when I want a perimeter, what I'm supposed to do. I'm supposed to add these factors, right? I'm supposed to add these because I want the perimeter. I have to add 1 with 72. I have to add 2 with 36. I have to add 3 with 24. Likewise, I need to add all these factors. Therefore, this question is nothing but what? Sum of the factors, but 2 times. Because in the perimeter, if I'm writing this as, look at this, 1 and 72, 1 is coming here and 72 is coming here, but there is a 1 on the other side of the dimension as well. And there is a 72 here as well. In the sense, what is this? Similarly, if you take a look at 8 versus 9, hey, there is a 8 as a factor, there is a 9 as a factor, but 8 I need to duplicate on the other side as well, because I'm talking about perimeter, and 9 I need to duplicate it here as well. And then what is this particular question? Having read this particular question, you say, hey, this is 2 times of sum of the factors. After reading this question, you realize this question is about 2 times of sum of the factors, nothing but the perimeter of all possible rectangles. Guys, are you clear on this? Are you clear on this? Are you clear on this? Don't expect that they will throw questions directly, right? Sum of the factors, how much, tell me. No, they will create a roundabout application. We need to realize that this guy is technically talking about sum of the factors. Of course, it's twice because it's a perimeter. Perimeter, I need to duplicate each factor there. Everyone clear about this? Clear about this? 2 times the sum of the factors is clear. Twice the sum of the factors is clear. Right, how do I find the sum of the factors? All right, if there is a number written as prime 1 raised to power a, prime 2 raised to power b, and prime 3 raised to power c, right? Prime 3 raised to power c. How do you do this? Therefore, you say that sum of the factors of the number is, you look at this, all right, this is technically sum of the terms in GP. All right, it would become sum of the terms in GP. Aradhya, if you are not understanding, don't worry. Don't worry. Can't help it. Now, don't spam it. Don't spam it. Because by typing it 10 times, it doesn't make the case stronger. Right? Yeah. So, not understanding, leave it. Leave this concept. Leave this concept. Follow some other concept. Don't spam it. Right? For heaven's sake, don't spam it. So, it doesn't make nice sense to tell the technical team to ban you from this, all of that. Don't spam. Right? Don't spam. No need to spam it. Because you type it 100 times, it doesn't make the case stronger, right? We all know that logic. Okay, yeah. Subtly, you can leave the meeting, right? So if you are not understanding, why bother? Because you may have to start from the basics. I'm doing the application based here, right? Yeah. So let's respect that space. We have taken a decision to do it this way. Allow us to do it that way. Fine, let's come back. Let's come back. So how do we find the sum of the factors of the number? Prime 1 raised to power a plus 1 minus 1 divided by prime 1 or divided by prime 1 minus 1. This is what you kind of write there. So how do we write? This is what? This is sum of the n terms of the GP, right? I'm not proving this, but the proof comes from sum of the n terms of the GP. You look at this. From here, you write this as prime 2 raised to power b plus 1 minus 1 divided by prime 2 minus 1. That is how you kind of write, all right? So similarly for this also you kind of write this. Now let me go back to my number 1440. Hey, what is this 1440? 1440 from here, 1440 is nothing but 2 raised to power 5, right? Because 2 raised to power 5. Then you have 3 raised to power 2 into 5 raised to power 1. This is this particular number. From here, you say that, hey, sum of the factors of 1440 is what? 2 raised to power 6 minus 1 divided by 2 minus 1. And you look at the second one, already you look from here, 3 raised to power 3 minus 1 divided by 3 minus 1. And from here, you would write this as 5 square minus 1 divided by 5 minus 1. I don't think it takes much time to address this. It's not a big deal here. So therefore, the first number is nothing but 63. The second number is 26 divided by 2, which is 13. The third number is 24 divided by 4, which is nothing but 7. Sorry, which is nothing but 6. 6, right? We kind of multiply these particular numbers, right? Multiply these particular numbers, but this is not the answer. What is your answer? You got to double this particular. You got to double this particular number because required answer is 2 times the sum of the factors. This is the sum of the factors which you got to double. I think some of you who answered before, you answered this as the answer. probably you may have to double and answer this particular question, right? So you may have to double and answer this question. Appropriate answer is option C. Right? Appropriate answer is answer C. Make sense? Clear, everyone? Clear? Everybody clear on this? Did it make sense? Did it make sense? Everybody clear? Quickly confirm. All clear? All good? Okay. Harish is clear. Prashant is clear. Mohit is clear. Others, hey, did you get sense of this? Yes, no? Quick, guys. Have you guys gotten sense of this? Okay. Now, why don't you guys answer? If I just remove this 0, I'm saying that, hey, all possible rectangles as well as squares, whatever, all possible rectangles as well as squares are drawn whose area is 144 and the sides are integers. Find the sum of perimeters. What I'm saying is just take off this 0, make it 144. What is the answer? Type it, type it. It's a small number. Everybody calculate and type the answer. Go ahead. Everybody go ahead. Calculate and type the answer. Right? 144 is the area. Sides are integers. What is the sum of the perimeters of all possible rectangles that can be drawn? Go ahead. Everybody answer this question. Okay. 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 All right. All right. All right. Very good. Listen, all of you listen. All of you listen. Listen, guys. All of you listen. All of you listen here. So one of the rectangles, listen. Okay, good, good. All right, I read your numbers. I read your numbers, answers. So listen, all of you listen. The side, all right, I can write it like this: 144 into 1. That's also a rectangle, right? 144 into 1 is a rectangle. 72 into 2 is a rectangle. Likewise, you can keep writing this, right? So you may say that, sir, 36 into 4 is another rectangle. No problem. You can keep on doing it. And towards the end, because 144 is a perfect square, it would have odd number of factors. One of the factors will be 12 and there will be nothing opposite of that. There would be nothing opposite of that. Trust me, there would be nothing opposite of that. What I meant is this. You got to listen very carefully to this, right? Because 144 is a perfect square. It would have odd number of factors. There is a pair for this. 144 into 1. Hey, there is a pairing for it. If this is 1, this is 144. Fair enough. Okay. Now there is a pairing for this. 36 into 4, there is a pairing. Hey, there is a 4 here and there is a 36 here. It's a box. When I say the dimension is 36 by 4, it's a 2D. Now what I'm saying here, 12, that's it. You can't say that, hey, I will write 12 one more time. No, man. Factors is there is only one factor called as 12. It's a straight line. It's a straight line. When you wrote this 12, it's a straight line. Hey, you how can you produce a box out of a straight line? Now therefore you say that, hey, I will add a dummy first. Listen, this is 12, which is a dummy, which was not there as a factor, which was not there as a factor. I'm adding this dummy. Now I'm forming a box. Because I added a dummy, I'm adding a box. This 12 comes here and this 12 sits here. Now what you are trying to say, hey, I need a duplicate of this, correct? Because that has to sit on the opposite side. I need a duplicate of this. I also need a duplicate of this which sits on opposite side. Meaning, listen to this very carefully. So what you got to do is, the sum of the perimeters is sum of factors plus root 144. Hey, what is this root 144? Root 144 is this 12 which didn't exist. This 12 did not exist. It was a straight line because already now when you wrote that 144, it has odd number of factors. Towards the end, only this particular 12 was left. It was only this particular 12 was left. It was a straight line. When this 12 was left, it was a straight line. Therefore, you made a deliberate attempt to tell that I will introduce another 12. If you introduce another 12 along with the sum of the factors, you please write another root 144. What is root 144? Write another 12. Now you double this particular number. This is what happens when it is a perfect square. Did you all understand this? Convert the line to box. That is the common mistake people do. When it becomes a perfect square, this problem occurs. Towards the end, there will be a straight line. There will be a straight line. So therefore, it is not just sum of the factors. You are adding perfect square. That is 12 you are adding again. You can directly add 12 also here. Nothing but root 44. And then double it. And then double it. Did you get this message loud and clear? Did you understand what I tried to say? Guys, everyone, did you understand what I tried to say? Answer later, guys. Did you understand what I tried to say first of all? Hey, there is a difference, isn't it? We were crying through the class. We were saying that if the number is not a perfect square, if the number is not a perfect square, it has even number of factors. If the number has even number of factors, you will always get a rectangle. But the point is, what if the number is a perfect square? If the number is a perfect square, it will have odd number of factors. If it has odd number of factors, one factor will not have a marriage. In the sense, it will not have a pairing. Then you deliberately pair it. No, then you deliberately pair it. If you pair it, you got to double this also and you got to double this also. Where did you pair this? You paired it here. Root 144 is nothing but the pair. Oh, I don't want to write root 44. Then write 12. Yeah. Then write 12. Then write 12 and then double it because this 12 also needs to be doubled and this 12 also needs to be doubled. This 12 is a part of the sum of the factors, but this 12 what you wrote here, it was not a part of the sum of the factors. You brought it in deliberately. Got this? Harish, where you are splitting 144 into 12 here. These are factors, man. When you write the sum of the factors, why will you write any factor two times? Why will you write any factor two times? You didn't understand this box concept. To form a rectangle, you need two dimensions, right? 144 will have odd number of factors. How many factors are there for 144, by the way? 144 is nothing but 2 raised to power 4 into 3 raised to power 2. Number of factors are 5 into 3. It has 15 factors, man. Out of 15 factors, you will get 7 pairs. This is one pair, first pair. This is the second pair. This is the third pair. Like this, all it you would get all it seventh pair, and 12 will be left, which means 7 rectangles you get. This 12 will not have a pair, man. This 12 will not have a pair. Got it? So this becomes a straight line. If it does not have a pair, deliberately attach a pair by writing another 12 and then double this number also, double this number also. That is what I'm attaching before doubling. Understood? Understood? So these are the silly mistakes we do sometimes. So you need to pay attention to composite number, prime number, right? Perfect square, not a perfect square. Now these has to be handled little carefully, right? Composite number, the nature will change. So when we got those factors, we said that, hey, so n square has 15 factors, composite number. So then we dealt it little differently. N square has 13 factors, prime. So we dealt it differently. Similarly, perfect square, the number here was a perfect square, 144. We dealt it differently. The number is not a perfect square. We dealt it differently. We need to, whole point was what? I'm trying to illustrate that. Pay attention to these details. Composite and primes can behave little differently. Perfect squares and non-perfect squares can also behave little differently, and hence you need to be aware of this. Once you are aware of this, deliberately you will think about it. Once you think deliberately about it, you will get over those traps. That's the point there. Okay, let me stop here. Let me stop here. It's quite good time that we discussed. I'm hoping that everybody gained something out of this lecture. Why don't you put it in the comment? Have you all gained something out of this lecture? I spent over an hour. All right, I spent close to 70 minutes, I guess. Did you all learn something? Can you put that in the chat? How many of you learned something? You can just put it in the chat. Right. Good. Okay. Prashant learned something. Shivam, Nazia, Sumit, Mohit. Okay. Lasya. Okay. Okay. Right. Right. You Raj. Good. Yeah. Harish. Right. Perfect. That's pretty encouraging. That's pretty encouraging. Yeah, I will just tell you all right what is that we are coming out with for the next few lectures. Yeah, this is tomorrow. I will meet you at 10ish. 10 I meet you tomorrow. That's again we will do a cryptic cat set on games and tournaments. We discussed four concepts. So as we go, we'll kind of start exploring them. So we will do tomorrow again games and tournaments. 10 no lecture in the afternoon. We'll straight meet in the night. Those who also have the subscription doing the plus join me in tomorrow 25th. So I did two lectures here. The basics of PNC are kind of covered. I'm starting the application tomorrow. So those who want to join in, have the plus subscription, you can join me there. But that's at 6:30, 100 minutes. So these lectures are for 100 minutes. That's you can join if you have the subscription or so. Yes, if you have liked it, what we are discussing, the content, always press the like button before you leave, and then you can share the link with others. All right, and then subscribe to this particular channel, subscribe to these lectures of Cat Ninja so that whenever we start a lecture, you will have a pop-up, or whenever something is scheduled, at least you will get to know about that. Yeah, if anybody has not taken the cat combat, if anybody has not taken the cat combat, take it this particular Sunday, because one of you got 100% scholarship as well. One of you were mentioning in the previous chat that you got 100% scholarship. Good, because 200 people get the scholarship. Try your luck, because already there is 100% scholarship, 75% scholarship, 50%, 25%. Some scholarships you get, that would be pretty encouraging. I'm sure already now most of you are doing very intelligently in these particular lectures. You are doing well, so therefore getting scholarship is not a problem. I guess you will get at least 50 to 75% scholarship. Try it. It's just 1 hour test on Sunday. Try and write this particular test. So if you want to use it, you can use my code Belvi 100, and you can use this particular code and try the test. All right, guys, that brings me to the end of the lecture. So see you tomorrow at 10 in the same channel, or at 6:30 on the plus channel. So there we go. Good night to all of you. I will see you guys tomorrow night. Sleep well, eat well. I will see you as soon as I could. Bye till then. So any questions that you have, you can quickly put it out here. I will wait for a minute. Something to be asked, I will wait. If nothing, we can drop from the meeting and meet tomorrow again. Okay. Nazia says nothing. I'm hoping that. All right. So good night. I will see you guys tomorrow. Bye till then. Stay blessed.